Good morning, dear students. My name is Ferhan Mazher, and today is 17th of October 2021. The day is Sunday. And right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we are going to solve an ATP paper, alternative to practical. We call it paper 4. Today, we have set our hearts to solve October, November 2020. 4-2 paper. This paper 4 is from the zone 2, or you can call it variant 2. So let's start this ATP paper, and let me go to the question paper first of all. So here we go. So today we are going to solve October, November 2020 4-2 paper. ATP paper, alternative to practical. We call it paper 4. The time allowed is 1 hour. So let's quickly start this paper. Okay, so listen to this story carefully. He says, a student investigates the balancing of a meter rule. She uses a meter rule that has a small hole drilled through it at the 5 centimeter mark. She pivots the rule at the 5 centimeter mark. She supports the other end of the meter rule using a Newton meter attached to a loop of string placed at the 95 centimeter mark. She suspends a 200-gram mass from the rule using a loop of thread. The student moves the loop of thread supporting the 200-gram mass until it is at the 25 centimeter mark on the meter rule. Figure 9.1 shows the setup. So let me use the size so you can see the whole thing. So here, I hope now you can see that. So here we have that meter rule at the mark of 5 centimeter. We have drilled a hole, and by this rod, it is pivoted here. And here we have placed a mass of 200 gram. It's hanging with this meter rule by the help of a loop of thread, and it's at the mark of 25 centimeter. And with the help of a loop of a string, the meter rule is hanging with the Newton meter at the mark of 95 centimeter. So here you have your pivot, which is very important to understand. Here is a weight which is trying to produce a clockwise turning effect. Here is a meter rule which is applying the force in the upward direction. And if these two turning effects, they will be equal, this whole thing will be in equilibrium, and this meter rule will be in the complete horizontal position. So this is the story of this question, and let's move to the next part. He says, let me increase the size. She calculates the distance d of the mass from the pivot and records her value in the first row of the table 1.1. There's a table 1.1, I'll show you. So the d means where the mass is hanging. For example, here it is at 25 centimeter mark, and here is the pivot. So the distance between them, that's d. Right now it is 20 centimeter. 25 minus 5, that will be 20 centimeter. She adjusts the height of the clamp supporting the Newton meter rule until the rule is horizontal. She records the reading F on the Newton meter in the first row of the table 1.1. Table 1.1 is on the next page. The student repeats this procedure with the loop of thread supporting the mass at the 40 centimeter, 55 centimeter, 65 centimeter, and 80 centimeter mark on the meter rule. So what she do, she moves this on different locations. For example, she put it at 55 mark, 80 mark, 75 mark. So she moves this mass here on this, okay? Simple. So this is that table in which they are recording their readings, and this is the figure 1.2. This figure, let me see it. So that's the table in which they will put the values. He says A part is question number 1. A part is figure 1.2 shows the Newton meter reading when the 200-gram mass is placed at the 55 centimeter mark on the meter rule. So you can clearly see this is the reading which is coming on the Newton meter. So I can read this reading. Yeah. So their question is, question number A, first part is, in the table 1.1, record the distance D of the mass from the pivot. And in the table 1, the second part is in the table 1.1, record the reading F of the Newton meter. So we have to record these readings. This is the reading of the Newton meter. You can see 1, 2, 3, 4, 5, 6, 7. It's 1.7 Newton. And I can show you. Let me go to my answers. Okay. I will show you how this is done. Okay. So the value of the D, he said that the loop is at 55 centimeter. That mass, 200-gram mass, is here. The thread is here at 55 and the pivot is at 5. So this distance from 5 to 55, it will be 50 centimeters. So in your table 1.1, you will enter 50 centimeter. Then we have to read what's the reading on the Newton meter, and clearly this is 1.7 Newton. So now you can see that we have entered those values into that table, and that is the D value is 50 centimeter and the reading on the Newton meter is 1.7 Newton. Okay. So once you have done this, then they say the B part is, okay, then move to the next part. We're done with this. Then the B part. Question number 1 and its B part is coming up on your screen. He says, on the figure 1.3, plot a graph of F on the y-axis against the D on the x-axis. Start both axes from the origin. Draw the straight line of the best fit. There's a 4-mark question. The question number 1, B part, 4-mark question. So we have a graph here. You can see that graph is given here. So this is that graph which is given on the next page. So, okay, so this is that graph. And what we have to do is we have to plot a graph on this. So on the x-axis, I will take the D, which is in centimeters, and on the y-axis, I will take F. So this is something which we have to draw. Okay. So let me show you how we are done, how we will do this. So this is that table. So D, this D value is supposed to be on the D values will go on the x-axis and F values will go on the y-axis. So you can see that on the X values, the value will start from the 0 and the maximum X D value is how much? That's 75 centimeter. So according to this, I will make it. And the Newton meter reading goes up to 2.3. That these values are going to be on the y-axis. Okay, so here you can see that I have used my, on the x-axis I have labeled it that the D will be here and the D is in centimeters. On the y-axis I have labeled it with the F, means force, and the unit I am going to use is Newton. And then you can see that here 2 centimeter represents 10. So 10, 20, 30, 40, 50, 60, 70, 80. And on the y-axis, 2 centimeter is equal to 0.2. So 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2.0, 2.2, and 2.4. Then I will plot those values. Let me bring those values here. So these values, so at 20, I will put a mark of 1.1. At 35, I will put a mark of 1.4. These are X coordinate, Y coordinate, 50, 1.5, 1.7, sorry, 60, 2, and 75, 2.3. So these are the coordinates. So you can see I have plotted them, this point, this point, this point, this point, and this point. If you have the hard copy of this paper, plot these points like this, like we have drawn. We have plotted these points. And then he says, draw the line of the best fit. So here I have tried to draw the line of best fit. My line is little lower. It should have been a little higher. So when you draw the line of best fit, the basic rule is that the number of points which are left upward, the same number of which are above the line, the same number of points should be left under the line. So this best line of best fit is not very, you can say the best line of best fit. It's acceptable. So you can draw a better line of best fit. The number of points which are above that line, they should be equal to the number of points which are below that line. I've just drawn a line of best fit. It's not that best. You can draw a better line. Okay. Next part is, he says, and let me show you first of all the question, and then we can go to the next part. Okay. So the next part on your screen is that. Okay, so the next part coming up on your screen is, he says that calculate the gradient m of your line, show all working, and indicate on the graph the values you choose. So the values we have chosen, we will show them, and we have to show the working on the graph, and we have to find the gradient. Usually it's a graph which is a straight line graph. And I can find its gradient. That's very simple. You have learned in your mathematics. The formula for the gradient is y2 minus y1 divided by x2 minus x1. Or in very simple words, I say we take 2 points, make a right angle triangle by joining those 2 points with the 2 components which are perpendicular to each other. And we call one, the y component is called the rise, the x component is called the run. Rise divided by run will give you the gradient that you have learned in your mathematics. So let me show you how I have done this. Okay, so let me show. So here you can see that I have chosen this point and this point. This point is 20, 1.06. This point is 70, 2.16. This is the x component, this is the y component, this is called run, this is called rise. If you divide the rise with the run, you get the gradient. Okay. So here you can see that that's the C first part. I've taken 2 points, 20, 1.06 and 70, 2.16. The gradient will be y2 minus y1 divided by x2 minus x1. You have learned in your mathematics. So 2.16 minus 1.06 in the numerator, and in the denominator we will write 70 minus 20. So the answer will be 0.022. So the gradient of this graph is 0.022. It's a 2-mark question. Very simple and straightforward question. The second part of the C is extend your line so that it cuts the y-axis. Write down the intercept C that your line makes with the y-axis. So, okay, so let's check. So this is the y-intercept, and the value of the line of best fit which I have drawn is 0.6. So the y-intercept is 0.6. Then he says calculate the w, where w is equals to c by m. So c is 0.6, m is 0.022. Just enter these values in the calculator and you will get the answer 27.27. Then the fourth part is, he says the weight, capital W, of the meter rule is given by the equation shown. W is equals to W divided by K. This W is small w, and the K value is 22.5 centimeter per Newton. So just put those values, 27.3 divided by 22.5, and that will be 1.21. So 1.21 is the answer. So that is the question number 1. It's C part. Hopefully you have understood. Okay. So my dear students, these are the questions. Question number C first part, then question number C second part, question number 3 C, third part, and question number C. Then we have the fourth part. And then you can see that we have the D part. Okay. So the D first part is when performing the investigation, the student rests up spirit level on the meter, on the rule to check that the rule is horizontal before taking each Newton meter reading. So just why using a spirit level in this way is not suitable for carrying out the checks in this instance. So you see, if you put, for example, this is that meter rule. Look at this meter rule. So this is that meter rule. If you put a meter rule here, you see the reading on the Newton meter will change. So that will change the whole equilibrium. It will change the whole reading on the Newton meter. So you cannot put a meter rule. You cannot put a spirit level on the meter rule to check whether this this rule is horizontal or not. So we cannot use a spirit level here. So very important, the spirit level is the instrument which we use for measuring, for checking whether a thing is horizontal or not. Okay, so oh my God, we have too much. Okay, so we were here. So just by using a spirit level in this way is not suitable for carrying out the check in this instance. And then the next question, 1 mark question, is describe a method other than using a spirit level of checking that the rule is horizontal. So what you do, you see, try to understand this. This is how you do it. What you will do, you will take a, you will take a, let me show you the answer. Okay, so here we go. Here is, okay. I have not put those answers here, unfortunately. Let me give me a minute, and I will show you those answers. Just give me a minute. So you see, when I took the I was making that file, I forgot to put that diagram. It will take a minute. I'm sorry for that. It will just take a minute once my WhatsApp opens here. So, my dear students, let me show you the spirit level. Let me increase it. So here on your screen, this spirit level is showing. So in this capsule, we have liquid and we have a bubble in that liquid. When this bubble is in, when you put this spirit level on a surface, like this man has put this on a table, and if that bubble is in the center, that means that the table is perfectly horizontal. So this is called the spirit level. So let's go to our question, and the question was question number 1D part. He says, suggest why using a spirit level in this way is not suitable for carrying out the check in this instance. The weight of the spirit level will change the reading on the Newton. So that is our answer. The next question was, describe a method other than using a spirit level of checking that the rule is horizontal. So we can use a plumb line. So let me show you how I will. So where is that? Okay, so I will take a plumb line. Plumb line is basically a thread, and at the end of the thread, we have a metal ball. So what we will do, I will take a plumb line and I will hang it here. And I will check how much is the length of that thread from this point to this. The bob will be here. When the bob is almost touching the ground, and the thread is near this end, I will then check with the scale that what is the length of that thread. Then I will, from this end, I will use the plumb line, and the thread should be almost here, near here, will be in my hand like this. And the metal rod will be almost, just almost touching the ground. So whatever will be the length of the thread, I will check what's the length of that thread. If from both the ends, the length of the thread of the plumb line is same, it means that this horizontal scale, this horizontal rule is perfectly horizontal. Another method can be, you can put a scale here, you can check what's the height of this scale, the rule from the table, and check the height of this end of the horizontal rule from the table. If the height on both the ends is same from the table or from the bench, then it means this is perfectly horizontal. So this is how you can answer that. I have written also an answer, so let me show you. So we have written the answer which I wrote is that use a plumb line to check the height of rule from table. If height of both ends of the rule is equal, it is horizontal. If the height of both the ends of the meter rule is equal from the bench, that means that the rule is perfectly horizontal. So we are done with the question number 1. I would like to show you the marking scheme, and I have always told you that it's very important to have a look at the marking scheme. So here we go. So this is the question number 1. The whole of the question number 1 is showing up on your screen. You can do what you can do. You can pause the video and take your time, have a look at this marking scheme, check your answers, check my answers, and make sure that we have not made any mistake. To reading this marking scheme is very important. Okay, so we are moving, and let's go to the next question. The next question will be question number 2. So we are done with the question number 1. So we are going to question number 2. Okay. So on your screen, the question number 2 is showing up. A student investigates the resistance of two lamps X and Y. He sets up the circuit shown in the figure 2.1. So here we have a lamp X. We have put a voltmeter across the lamp X. Here we have an ammeter. This is the power supply. So this ammeter will tell you how much current is flowing through the lamp X, and this voltmeter will tell you how much voltage is taken by the lamp X. He measures the current I in the circuit. He measures the potential difference V across the lamp X. He replaces the lamp X with the lamp Y and repeats the measurements of the current and voltage. He removed this lamp, and here he put another lamp by the name Y, and he measures current, he measures voltage. He reconnects the lamp X into the circuit so that it is parallel with the lamp Y. Then he puts the lamp X back, but he put the lamp X parallel to the lamp Y. He measures the total current I in the circuit. He measures the potential difference V across the lamp X and Y in parallel. His question is, they are asking you a question, and the question is, the student's results are shown in the table 2.1. So here we have that table, the potential difference, the current, the resistance. Lamp X only means when there was only lamp X, lamp Y only when it means when there was only lamp Y, and when the lamp X and Y were parallel to each other. They both were there, but they were parallel to each other. So what are the voltage drop across them, and what was the current according to the ammeter? So they are recorded. So the question is the A part in the question number 2. He says, draw the circuit when the lamps X and Y are connected in parallel. So that's the first question, and it is of 2 marks. Question number 2, A part is we have to draw. We have to show that thing. Okay, so here we go. So here you can see that on your screen that is showing up. I have shown you the circuit, and you can see that the lamp X, this is the lamp X and this is lamp Y. They both are connected parallel to each other. Here we have connected a voltmeter, which will be telling you what is the total voltage drop across these two lamps. And there we have the ammeter, which is telling you how much is the total current flowing through these lamps. So it was a 2-mark question, question number 2A part. And the next part is, he says, before going to let's read the question first. So here we go. So we are done with that drawing of the circuit. Now the question is, they say that complete the column headings in the table 2.1. The column headings were, and the second part is calculate the resistors R for each lamp arrangement using the equation R is equals to V by I. Record your answers in the table 2.1. 1 mark these questions, and let me show. So here we go. So here is that table, the table headings, the column headings, the voltage, the potential difference. Here you have to write the unit. It is measured in volt. Current or IE, that is measured in ampere. Resistance, its unit is ohm. So for finding the resistance, the R is equals to V by I. That's the formula. And so the resistance will be here 1.4 in your calculator. Write 1.4 divided by 0.23, and you will get 6.087 ohm. 1.3 divided by 0.22, and the resistance will be 5.909. So 1.4 divided by 0.45, the answer will be 3.111 ohm. So this is question number 2, and it's B part. Okay, so let's check the next part. He says we are done with this B part. Okay, so then we have the question number 2, and it's C part. He says the student states that the combined resistance of the lamp X and Y when connected in parallel is equals to twice the average resistance of the lamp X and lamp Y. He is correct. He is incorrect. Sorry, he is incorrect. Use the results in the table 2.1 to suggest a correct conclusion about the combined resistance. It's a 2-mark question. So from the table, we have to show that his statement is incorrect. Okay, so let's go to our table, and I will show you. You see, the individual resistance of X when there was only X is 6.087. The individual resistance of the lamp Y when it was connected individually, means separately, there was only lamp Y in the circuit. That resistance was 5.906, approximately 6 resistance, individual resistance. When they both were connected parallel to each other, the resistance of the combined resistance was 3. So clearly, this is not the twice of their individual resistances. Rather, it is half the individual resistance. So his statement is wrong. So let me show you the sentence which I used. Resistance of the X is 6.087 and of the Y is 5.909 ohm. Combined resistance of X and Y when connected in parallel is 3.111 ohm, which is not twice, rather half of individual resistances of X and Y. So his statement is incorrect. So we are done with the question number 2. The question number 2 was of 6 marks, and let's have a look at its marking scheme. So question number 2 is coming up on the screen. Okay. So question number 2 is coming up on your screen, and you can see the marking scheme. I can give you advice that stop this video, pause this video, and take your time to check the marking scheme for the question number 2. I hope that you have understood this question. Okay, so we are starting the question number 3. A student investigates reflection and refraction of light using a semicircular glass block. He places a glass block on a sheet of paper. He draws around the outline of the block with a pencil. He uses a ray box to direct a ray of light onto the center C of the flat face AB of the block. He labels AB and point C. Figure 3.1 shows what the student observes. So this is the ray box. The light came, and here it has emerged from this semicircular glass block. Then he says he uses a pencil to place two crosses X1 and X2 on the incident ray. He uses a pencil to place two crosses X3 and X4 on the emergent ray, which came out. That's the emergent ray. He uses a pencil to place two crosses X5 and X6 on the ray reflected from the face AB. He moves the glass block and the ray box. Figure 3.2 shows the student's sheet of paper. So here we have that. So here is that sheet the student was using. So that is the figure 3.2. X1, X2, they are showing you the incident ray. X3, X4, they are showing the emergent ray. X5, X6, they are showing the reflected ray. So what are the questions? The first question is, draw the normal to the surface of the glass block at the C. The B part, first portion, is draw a line joining X1 to X2, continue the line to C. The second part is draw a line joining the X4 to the X3, continue this line to the C. Draw a line joining X6 to X5, continue the line to C. So let me show you. I have done this on a paper. So let me show you how we have done this. Okay. So question number 3, the A part, he asked us to draw a normal at the point C. So here you can see I have drawn a normal. A normal is a line which will be making 90-degree angle with the surface of the glass block here. So you can see here. So this red line is the normal. Then he said join X1, X2 with the C. So you can see that I have with the help of a scale, I have joined X1, X2 with the point C with this blue line. Then he says join X4 with the X3 up to point C. So here with this purple color line, I have joined them. And then he said join the X6 with the X5 with the C. That is the reflected ray. So here you can see. So this is the angle of incidence. You can measure it with the help of a protector. This is the angle of reflection. You can measure it with the help of a protector. And this is the angle of refraction inside the glass. And you can also measure it with the help of a protector. So let's move to the next part. That is question number 3, C part. He says, measure the angle of incidence I of the ray of light on the face AB. So I have shown you that where is the angle of incidence, just measure it and with the help of a protector, and that will be 35 degree. I measured it, it was 35 degree. Then he says measure the angle of refraction R at the point C of this ray, and that will be 22 degrees. Then he says in the D part, calculate the refractive index N of the glass, use the equation. The refractive index is represented with the N, its formula is sine I by sine R. So sine 35 divided by sine 22. So in your calculator, when you enter these values, the answer will be 1.53. So that is question number C first and second part. Then we have the question number D, he says. So C part is done, the D part is also done. Okay. Now we are moving to the question number 3, and it's E part. He says, measure the angle of reflection R of the light from the face AB. So when I measured it, it was 32 degrees. The angle of incidence I should be equals to the angle of reflection R. That's the law of reflection. The angle of incidence and the angle of reflection, they should be equal, but our angle of incidence is 35 while our angle of reflection is coming out to be 32. So there is some mistake. State one practical reason why the angle of incidence and the angle of reflection that you have measured may not be equal. One reason can be when he put the cross fifth and sixth, they are on the wrong place. So the crosses are not placed in the correct places. So there can be many reasons. The ray which you have drawn there, that might be very thick, and the crosses are not right, not in the right or correct position, and or the protector has not been placed properly. So that was question number 3. We are done with it. It was a 3-mark question. So let's have a look at this marking scheme. Okay. So question number 3 here is showing up. The question number 3, the marking scheme of the question number 3 is coming up on your screen. It is very, very important. Whenever I solve a paper, I always advise my students to check their work themselves from the marking scheme. It's very important. Okay, so that's you can pause the video and you can take your time with this marking scheme of the question number 3. But we are moving to the next question. Okay, so here we go. A student investigates the effect of using a lid on the speed of cooling of hot water in a beaker. So we know that if I take hot water, a cup of hot water, and I don't put a lid on it, it will cool faster. But if I put a lid on it, the cooling rate will be slower and it will take longer time to cool it down. So she pours 200 cubic centimeter of the hot water into a beaker. She places a thermometer into the water as shown in the figure 4.1. So you can see here we have a retort stand, and with the help of the clamps, they are holding a thermometer, and the bulb of thermometer is in this water. This water is hot. The volume of the water is 200 cubic centimeter, and this water is hot. She waits for a short time. She records the temperature of the water, and at the same time, she starts a stopwatch. This is at the time t equals to 0. Figure 4.2 shows the thermometer at the time t equals to 0. Record, so let me increase the size so you can see more clearly. The question is, the question number 4a part is the first portion. Record the temperature theta shown by the thermometer at time t equals to 0. So you can see this reading is 81, 82, 83, 83. So here you will write 83 degrees centigrade. Degree centigrade is already written there. You only have to write 83. Add your value of temperature to the table 4.1 on the page number 12. So on the next page we have that table. I will show you that table. We have to put that value there. Then they say state why the student waits for a short time before the reading of the thermometer at the time t equals to 0. So when you have poured hot water and you have put a thermometer, you do not immediately start your stopwatch and start noting down the temperature. You put the thermometer into the hot water, and then you wait for a few seconds. You check the thermometer, the reading of the thermometer, the mercury level will go up, 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 up. When it becomes steady, when it reaches its maximum value, after which it will stop there and then start coming back. So you have to wait for the mercury thread to go to its maximum height. You give time, few seconds for thermometer to thermometer, so that it can come in thermal equilibrium with the hot water. So it can show the maximum temperature the water has. So you give time. You do not start as you put the thermometer into the water, you do not immediately start the stopwatch. Okay, so that's the reason. Let me show you my work. I have also written. Let me show you. So question number 4, A part. First, and the second is showing up. 83 is the reading, and the second portion is allow the thermometer to reach the maximum temperature due to hot water, or the maximum temperature the hot water has. You should give some time to thermometer. So this is that table in which in the A first part, they ask you to put that temperature value. You can see I have written here 83 degree. Okay. So the next question is, he says, explain how the results in the table 4.1 show that the water cools more quickly without a lid. So it's a 1-mark question, but you have to answer and from this table. You see, this is without lid. So the initial temperature is 83, the final temperature is 65. In 5 minutes, the temperature has dropped from 83 to 65. So there is a drop of almost how much? There is a drop of 18 degrees centigrade in 5 minutes when the water is without. So if you look at the data on with the lid, the initial temperature is 85, the final temperature is 80. So it means there is a drop of 5 degrees centigrade temperature in 5 minutes. So when you are without lid, the temperature drop is 18 degrees centigrade in 5 minutes. And when you are with the lid, the temperature change is just 5 degrees centigrade in 5 minutes. So this is the argument which you have to write. So let me show you. I have tried to write this. Okay. Change in temperature 18 degrees centigrade in 5 minutes without lid. Change in temperature 5 degrees centigrade in 5 minutes in 5 minutes with lid. So you don't have to write this 2 times. So let me cut it. I just overdo this. You don't have to write this. Okay. So in 5 minutes with lid. So you can see without lid, it has the temperature drop is quick, is faster. The cooling rate is faster without lid. The C part is, he says, name one quantity that the student must keep the same to make a fair comparison between the speeds of cooling of the 2 beakers. Okay. So the beakers should have the same material. The amount of water in both the beakers should be same. They should have been put into the same environmental conditions. And the initial temperature in both the cases should be same. So these are the few of the things. You only have to mention one. So for example, you can say same volume of the water, or you can say same initial temperature of the water. So this is question number 4. It was totally 4 marks and it's done. And with this paper is also over. So let me show you the marking scheme of this. The question number 4's marking scheme is coming up on your screen. My dear students, what you can do, you can pause this video and have a good look at this marking scheme for question number 4 and take your time with this marking scheme. So today we have solved, I can show you. Okay. So today we have done October, November 2020 Physics 5054 4-2 paper. This was an ATP paper. We call it paper 4 or we call it ATP, alternative to practical. And this paper 4 belongs from the zone 2. So I hope that this video will help you to understand or to solve this paper, not just solve it, but also understand the concepts behind these questions. If this video is helpful to you, my dear students, don't forget to subscribe to my channel and like my video. And one very important thing, if this video, you find it helpful to you, share it on your Facebook, the link of this video, share the link of this video on your Instagram, because when you share it, and that helps me and that appreciates me. and I get energy, I get appreciation, and I get the fuel to continue my work. Hopefully, I am to some help to you. It was a pleasure teaching you all. Thank you very much, everybody. Have a good day.